In today's world, technology is driving our every move. And behind much of this technology is one powerful programming language, Python. Python was created in the early 90s by Guido van Rossum with a simple goal: to make programming as easy as possible. Inspired by the BBC show Monty Python, Python aimed to bring humor and simplicity into coding. Today, Python powers everything from web applications to artificial intelligence. Let's think about how we categorize things in everyday life. We often group items based on their characteristics. For example, we say, I have 5 apples. That's a number or integer. Numbers are used to count and measure. Or we ask, is the store open? That's a yes or no, a boolean. Booleans help us make decisions based on true or false conditions. We use lists to keep track of our daily tasks. Lists are ordered collections that can hold multiple items. We store contact information using dictionaries. Dictionaries hold key value pairs, making it easy to retrieve information. And we use tuples to represent coordinates. Tuples are immutable sequences, often used to store related pieces of data. We also use strings to represent text, like the words in a book. Strings are sequences of characters. Just like in real life, Python helps us organize data using types like integers, strings, booleans, lists, dictionaries, tuples, and more. In Python, data types are the foundation for manipulating information, whether you're working with simple text or complex datasets. Understanding these types is crucial for effective programming. By mastering data types, you can write more efficient and readable code, making your programs more powerful and versatile. Every day we repeat actions. We brush our teeth, we eat, we work. These repetitive actions are exactly what loops in Python help us perform, automating tasks so we don't have to do them manually over and over. A for loop helps us repeat a task a known number of times, like iterating over a list of groceries, while a while loop continues until a condition is met, much like counting down the days until a deadline. Think about how we practice skills. We exercise regularly, practice a musical instrument, or study for exams. These are all repetitive actions that can be mirrored in Python loops. Nested loops allow us to perform more complex tasks, like iterating over a matrix or handling multi-dimensional data. We often set timers or check calendars to manage our time. Similarly, loops in Python can be combined with conditional statements to create powerful control structures. Imagine using a to-do list app. Each task can be managed using loops, ensuring that every item is addressed efficiently. Cooking often involves following a recipe step by step. In Python, a loop can iterate over each step, ensuring nothing is missed. In gaming, characters often repeat actions. Loops in Python can control these repetitive actions, making game development more efficient. Fitness trackers monitor our steps and activities. Python loops can be used to process and analyze this data, providing valuable insights. Smart home devices automate daily tasks. Python loops can control these devices, making our lives more convenient. Managing finances involves repetitive calculations. Python loops can automate these calculations, helping us manage our money more effectively. Planning a trip requires organizing many details. Loops in Python can help automate this process, ensuring a smooth and well-organized trip. Weather apps provide forecasts by analyzing data. Python loops can process this data. delivering accurate and timely weather information. Chatbots respond to user queries repetitively. Python loops can manage these responses, making interactions seamless and efficient. Recommendation systems suggest products or content. Loops in Python can generate these recommendations, enhancing user experience. Search engines process numerous queries. Python loops can handle these queries, providing relevant search results quickly. Translation apps convert text between languages. Python loops can automate this translation process, making communication easier. Virtual assistants perform various tasks. Loops in Python can manage these tasks, making virtual assistants more efficient and helpful. Now think about cooking in the kitchen. You often follow a recipe, a set of instructions that tell you what to do step by step. In Python, we use functions for similar tasks. For example, you can create a function to calculate the total cost of items in a shopping cart. Python has many built-in functions like print, but you can also define your own recipes or user-defined functions to solve specific problems, like converting temperatures from Celsius to Fahrenheit. Just like in cooking, where you might adjust a recipe to suit your taste, in Python you can modify functions to meet your specific needs. Sometimes you might encounter errors or bugs in your functions. Debugging is like troubleshooting a recipe that didn't turn out as expected. You test and tweak until you get the desired result. To define a function in Python, you use the def keyword, followed by the function name and parentheses. Inside the parentheses, you can specify parameters. These are like the ingredients you need for your recipe. The body of the function contains the steps or instructions, just like the steps in a recipe. Once your function is defined, you can call it whenever you need it, just like referring back to a recipe. And when everything works perfectly, your function produces the desired output, much like a well-cooked meal. Often functions return a value using the return statement, which is like the final dish you serve. After cooking, you clean up and organize. Similarly, in Python, you can refactor and optimize your code to make it more efficient and readable. Reviewing and refining your functions ensures they are efficient and easy to understand. Just like a well-organized kitchen makes cooking more enjoyable. In real life, everything around us is an object, a car, a phone, or a person. These objects have unique characteristics and functions. Each object has certain attributes and behaviors. For example, a car has attributes like make, model, and year, and behaviors like starting the engine and honking the horn. In Python, we use object-oriented programming, or OOP, to represent real-world objects. OOP allows us to create classes that define the attributes and behaviors of these objects. For instance, we can create a class for a car with attributes like make, model, and year, and methods to start the engine and honk the horn. This class can then be used to create multiple car objects, each with its own unique attributes. Similarly, we can create classes for other objects like phones and people. A phone class might have attributes like brand, model, and operating system, and methods to make calls and send messages. A person class might have attributes like name, age, and occupation, and methods to walk, talk, and work. By using OP, we can model complex systems in a way that is intuitive and easy to understand. OP makes Python a powerful tool for building complex applications that resemble the real world. It allows developers to break down large problems into smaller, manageable pieces, making it easier to design, develop, and maintain software. With OP, we can create reusable code which saves time and effort in the long run. It also promotes code organization and readability, making it easier for teams to collaborate on projects. In summary, object-oriented programming in Python is a powerful paradigm that helps developers create robust, scalable, and maintainable software. By modeling real-world objects and their interactions, OOP makes it easier to build applications that solve complex problems efficiently. But why Python for AI and machine learning? The answer is simple. Python's simplicity, vast libraries, and community support make it the go-to language for developing cutting-edge technologies. With libraries like TensorFlow, PyTorch, and scikit-learn, Python allows developers to quickly build models, train machines, and deploy AI solutions that are changing industries from healthcare to finance and even space exploration. So, why should you learn Python? Python is not just a language for programmers, it's for everyone. Whether you're analyzing data, automating tasks, or diving into AI, Python gives you the tools to shape the future. Python's versatility, simplicity, and power have made it one of the most popular languages in the world. And with AI shaping the future, Python is your gateway to endless possibilities. Python is the key to unlocking the future of AI and machine learning. It's time to start your journey. Where will Python take you? Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and share. Let's build the future with Python.